And I'm very happy to open this and to host the event, which doesn't seem to be quite technically online, but mentally and intellectually it is. And we thank all of you, the speakers and the organizers. People have joined us here from the CITI family. Alex Wolfson from Munich or Berlin has been with us for many years. And thank you very much, Bob Cohen and Jason Buckweitz, who is trying to hold this thing together now technically, and Corey Spencer. So let me just say a few words about the topic. Private networks in 5G. And that, I think, is an important topic. And to take the bigger picture here, why are we talking about private networks at all? Private networks are a classic case of the trade-off between a standardized product and a specialized product, a standardized arrangement and a specialized arrangement. The standardized arrangements have as going for them economies of scale and network effects. Everybody can connect with everybody. But you also have specialization and customization and purpose-built and control, just so. So they're just there too, of the average and the specialized. It's an internal trade-off. It's been around forever in all kinds of human activities, and it's just in telecommunications, of course. It's been big from the beginning because there are these huge fixed costs, the low marginal costs, the high network effects. And so people have kind of from the beginning gravitated to the shared solution, but not only to the shared solution, because from the beginning, there were also different arrangements, more specialization, for more segmentation. So we have that already in the telegraph 150 years ago, in wireline telephone probably 100 years ago, and now also in mobile wireless. So between the fully specialized and the fully, let's call it shared arrangement, there have been several intermediate arrangements, and private networks is one of them. But we also have kind of interesting, and the internet is a good example, we also have an intermediate arrangement of private arrangements which are linked to each other. The internet, after all, is a network of LANs, local area networks, which are classically private network type arrangements, but they link together into this kind of global and international arrangements. So you can have, in a way, both. You can have interconnected private networks, and you can have public networks that are segmented, these virtual private networks that are really basically riding on the shared arrangements. So they're interesting intermediate arrangements. And what we are now exploring here in this conference is that model of the intermediate arrangement, the private networks now applied to 5G. 5G, of course, has been an exciting topic and much talked about, but it's been less talked about in that organized way as a internal means of production. And that is one of the things that Bob Cohen has brought to this conference and to CITI, the interest and the application of communications media, not only as an end product, entertainment and news, etc., but also as an intermediate product into processes that go beyond media and do stuff that might be somewhat less in the news, but such as manufacturing. And so that is the topic for today. We are very happy to have you here as speakers, and hopefully the audience will be able to join us too. That is the bigger picture that I wanted to provide. And now I'd like to welcome Bob Cohen to open the conference itself. Let me just say two words about Bob. He is an economist, and one of his specialties, among many things that he has been doing, is to analyze the emergence of cloud computing and how it affects the Internet of Things, machine learning, AI, and how these things have affected firms, technology, use, and the impact on the economy. He's done many things, and in particular, he directs the Economic Strategy Institute's project on the economic impact of cloud computing, IoT, AI, and machine learning on the US economy. So this is a really exciting perspective that he represents, and we're very happy to have him here as the leader of this conference. Go ahead, Bob.
Thanks very much, Ellie. I just wanted to give a few examples of why 5G private networks are important at a higher level. I think this involves on the enterprise level, which has been mentioned by Ellie, and also for the telcos. So on the enterprise level, I see a number of major impacts. One is that using 5G, particularly in smart factories, with a great deal of free connectivity between equipment using sensor networks, leads to a great deal of efficiency that there's much takes much less time to create products, and the number of products that can be produced goes up dramatically. So we have examples of the Siemens plant in Germany that makes printed circuit boards that can do 300 different types of circuit boards a day. And one usually doesn't see this kind of variety or flexibility in the traditional factory. The other thing that that I've looked at is the development of a knowledge platform. So if a company is running something like in the Siemens case, where they know how to produce a single printed circuit board, they can put that together with the software, with the AI analysis, and essentially create a template that can be used or modified to create other products. So that's a similar example to the one I gave before. I think both of these are examples of changing or improving internal value chains, where the ability to produce things is really improved dramatically. I think we've also seen this in the pharmaceutical industry in the creation of new vaccines for COVID, where the producers, who I believe are using almost a 5G network, have been able to cut the time to develop the vaccine to about a few months. The other thing that's very interesting, which I've seen in about 3 or 4 factories, is the ability to do customization, which I've called personalization at scale. The best example of this is the Mercedes-Benz Sindelfingen plant, where many cars are taken off the production line and put at intelligent workstations. And as a result of having 5G and a lot of sensors and automatic guided vehicles, the workers at those workstations, who are much more technically skilled than other blue collar workers or blue tech workers, are able to call all of the parts they need to do the customization. And thanks to digital twins and virtual reality, they can see how the part's supposed to be assembled, and also check that it's working properly. The other way in which enterprises are using 5G private networks is for bandwidth slicing, where a very data-heavy operation like welding needs a great deal of bandwidth and a very low latency, so that the results from the analysis using AI can come back to the factory right away. So this is, in the case of the UK Ford factory, done in a local network, which I think is set up with Vodafone. And what they're able to do is dedicate much more bandwidth to receiving all the data from about 1,000 welding operations that are then evaluated very rapidly, so that the quality of the welding for an electric battery can be evaluated quickly. The other dimension of this is what's happening to the telcos as a result of 5G being used in industrial settings. I think one very interesting thing is telcos playing a role as an intermediary, that where a company is using bandwidth slicing in a facility, that they can link up to a network that has an ability to also handle bandwidth slicing and transfer the information from what it's doing in factory 1 to what's happening in factory 2. So the role of the telcos or carriers as a carrier of specialized 5G operations is also there. The other response from the telcos has been to provide 5G private network access at the edge. So you have a case of Verizon and AWS wavelength capabilities being offered in San Francisco and Boston, where not only 5G, but also AI storage and compute power and software applications being offered at the edge. So this is another response in the way that telcos are handling 5G. And the other dimension that comes out in this is that a lot of telcos are working at becoming much more like cloud service providers. A good example of this is AT&T and its Acumos project, which started about 3 years ago. It's an open source effort, and AT&T has now developed a airship new open infrastructure project to offer open source computing to a lot of the customers that would like to use 5G and more smart factories. So that's a broad overview of how 5G private networks are affecting not only enterprises, but also reshaping the world of service providers. Okay, so if we can move on to the first panel now with Alex, I'll turn it over to him.
Great. Thanks a lot, Bob. It's good to be back. Once upon a time, I was sitting in the halls of Uris Hall and running these conferences. Great job, Jason and team, for keeping it all together. Years in being on the other side of the world, we're looking at these sort of connected devices from a consumer perspective, and I think really are going to see a sort of view of really the machine to things, how we buy from everything from autonomous driving, which we're looking at very seriously at BMW, to the shop floor technologies. So I know we've burned up a bit of time, so I just want to jump straight into the panel, and I want to introduce our first panelist, Fareed Baraka, who's founded, done a lot of stuff, founded 7 businesses and organizations. He's been focusing on innovative wireless technologies for the resilient wireless communications for smart factory via 5G and technology Li-Fi 6G. So I hand it over to you, Fareed.
Sure. Thank you so much. I appreciate that. Let me see if I can share my screen, and please let me know when you see it. I know I have very limited time, right? We're going to stick to the 10 minutes. Correct, Alex?
Yeah, let's try. Yeah.
Okay. So can you guys see my screen right now or not yet?
Coming up. Yep.
So I put it in presentation mode. I go very fast. Generally, what I'm going to discuss would be a little bit more high level from the discussion of the wireless communication, which is specifically goes to the private networks. Past many years, everybody is focusing on 5G and looking at it, but still 5G has limitation that's coming, some being resolved, especially with the 16th release that has been 16th release that has been released actually in July with 3-4 months delay, but still we have some issues. So I'm just going to look at very quickly on the interoperability of the wireless communication, especially for private network, and industry. As you know, most wireless communication has not been designed for industry. But 5G specifically has been designed for industry, and that's a good thing. But very quickly, just one thing I want to make sure everybody knows: we're talking about data revolution, and that's why we're coming to the wireless communication demand being doubled every year. Again, I don't devices connected as far as connected devices like IoT and different things, and the amount of the data that we need to send to the cloud or look at it in real time, it's going to be 90 zettabytes. So, and a lot of these things that we're talking about, like cloud, fog, Industry 4, smart factory, intelligent manufacturing, I'm just putting some of them out there. None of them has been 100% utilized by the industry. So we see just very little of them. Just give you an update as well. Like, for example, on the 5G implementation worldwide, by now we have 135 projects deployed. 4G for LTE4, we have 330, and so you can compare where we are as far as when we're talking about demand for the wireless communication going forward. So one of the important things in interoperability is we need enough data pipeline. That's one of the reasons that we went to the 5G specifically, because as you know, you can see this radio frequency map that it's already saturated. So do we have data pipeline enough? Do we have a secure and safe way of wireless communication? That's a lot of breaches on the industry happen, and a smart factory, especially when you get to the sensitive industry, that would be very important. Another important part is talking about scalability. That's very important. And also, this scalability is not only about the amount of the data that you need to transfer to your cloud, to your edge, but also about the power consumptions that you have for these devices. Now, again, with the 16 release and with the advancement of the technology, the power consumptions for 5G also devices is a little bit in a better situation. Do we have in fast and real time wireless communication? As you know, when you go to industry, when you have your private network working, what's important is to have the real-time data, because the decision needs to be made as soon as possible. So you need to have the low latency, or what they call it, the reliable low latency delay, which 5G also promises to the certain level, but not applied for all of the application. Again, 16 release that came out from 3GPP by July fixed some of those and provided a better delay, less delay, or I would say low latency. But still, it's not there for many applications, especially when you get against sensitive TSN networking, especially, or time-sensitive networking. Still, you have some shortages there. And the thing is this: by nature, when you go to industry, some of the environmental situation will impact our wireless communication, and vice versa. Our wireless communication impacts some of the devices that we have in the industry. So electrical magnetic interference is one of other issues and interoperability challenges that the wireless communication has, and 5G still also look at that. Another one is the accurate positioning. Again, when we came to July and 16th release, we got 5G to be able to do 3 meter accuracy at 80% of the time. So you can have your AGV robots, drones, lift trucks within your facility to be enabled by 3 meter. But a lot of, again, industry and a lot of applications goes there that requires much more accurate than 5G. So these are just the quick interoperability challenges that radio frequency and also 5G has. And these are requirements that IoT devices and private network for the industry requires this to be responded to have a complete utilization and a proper deployment in a commercial way, and can basically utilize it for everywhere or every facilities that they have. Just a quick look at of the wireless communication. From the millimeter wave especially, and then nanometer wave, that I want to talk a little bit about it as a new sixth generation to be looked into in future. That's what we're proposing. Don't want to bore you here. Everybody knows this. We came from 2G, 3G, 4G, and now 5G 16 release, and 17 release will be probably somewhat end of 2021 or 2022. But if you look at on the left side, you see we came to the centimeter wave, and then we came to the millimeter wave. I put this here not for everybody also to see the history, but also to think about it. What after? Still, we have some shortcomings that what we're talking about. Of course, some of them will try to be resolved by 5G. But of course, the next one will be nanometer wave. And what is that nanometer wave? We're automatically talking about the light, talking about something that we have it as now that the LED dominates our life and our buildings and our facilities. Now we have it everywhere, and it's part of our life. And also the nanometer wave for as part of the spectrum for wireless communication would be light, which what we call it now Li-Fi. Just a quick look at it, nanometer wave against the nanometer wave from the safety perspective, medium to high, from the power consumptions, again, you see high to low, from the cost also high to low, because the light is there, because you have that. And from the licensing partially free, that's again, what we discuss right now, the 16 generations that helps a lot on the private networking is to include some unlicensed spectrum on the 5G as well, but if not, is completed. So that helps on the private networking, but again, still not completed. Why I'm mentioning this? I'm looking at the 5G's shortcomings because I'm trying to explain there is the 6th generation coming, that these two together can be that networking, that wireless communication that we require as a reliable wireless communication in our industry. Quick look at it. When we talk about the light spectrum, we're talking about RF has 0.3 terahertz, but when we talk about the Li-Fi or light spectrum, we have 780. Of course, 2,600 times larger than RF, so give us more capability, more bandwidth. Has not been used, so it's free. You do not need the licensing, especially when you get to the private networking. No interference, electromagnetic interference. Of course, safe for human body. Does not go through the wall and has less energy consumption, and it's green. Quickly, this just wireless communication. I skipped this one for you guys. What is Li-Fi? Basically, what we do, as you know, the Morse code through the light for the Navy, we do the same thing. Thanks to the advancements of the LED lighting, now you can modulate the light and create 0 and 1s with the megahertz of frequency. So you create so many of 0 and 1s that can cover your area that the light is available. And that gives you a lot of data. So we're just changing the intensity of the light with the Li-Fi module. So basically we get the data encoded into the power, and then very simply that becomes Li-Fi for us. This is a real, actually the picture that you see is a real product of Li-Fi that we have, which we now enabling it 5G and Li-Fi together with a system that I explained very quickly, DDS, basically, that help us to make sure no packages will be lost, because Li-Fi also have some interoperability challenges and shortcomings, which together 5G and Li-Fi can help and enable our private networking specifically for the industry in future going forward. Just a quick look at it. By 2024, we estimate 1.5 terahertz data to be transferred. If we look at all the spectrum of the radio frequency, which is 0.3, we shortfall 5 times. While we have this amount will be only 2% of our Li-Fi bandwidth. So just to keep that in mind when you look at it worldwide and global. Of course, light has a lot of good things because we have it everywhere. Of course, we have it less than milliseconds latency, less power consumptions. There are some basically, it's not only line of sight, but also you can use it as a non-line of sight communication, which is you have the reflection of the light, you have mobility handover, multi-user, co-channeling interference, and all those kind of stuff. And most importantly, again, I want to mention about the DDS that comes to help for the Li-Fi, EMI-free, high-speed, secure, low-latency, license-free. I don't want to talk about those. Now let's look at just the challenges. What happens is your receiver actually...
We're running a little on time.
Sorry?
So just to be... We're running a little long on time, so if we could just try to...
Okay, I'm just wrapping it up. So I just want to say very quickly, there are shortcomings that Li-Fi has. We also 5G has, because they're millimeter wave and nanometer wave, so they're very, very similar to each other from the spectrum. But there are still shortcomings from each of them that 5G and Li-Fi can solve. IoT would be one of them. Light positioning would be one of them, which helps to do right now millimeter accuracy in the industry. We have for AI and VR, you can enable them with the Li-Fi, with the high, not only positioning, but also communications. We have autonomous lift truck, AGV, and drones that can be enabled with 5G and Li-Fi together. There are applications such as Hyperloop that you cannot still use 5G, but Li-Fi can be applied to those, and especially another one would be like underwater communication. With that being said, I wrap it up to be on time, and there are many other applications that if there was a question, I would be answering.
I think we'll
Thank you so much.
For Q&A. Thanks. I think it's also always very important that we sort of get into new technologies. We don't create technology for technology's sake. We create them to be used, and we really need to understand what's the business requirements for these new technologies. A lot of interesting stuff there. I think we have some, let's sort of say, I'm happy if the other panels want to sort of come in and sort of, let's sort of say, bring into your presentations feedback on 5G, liabilities, what's coming next. And so happy to move into the next presenter. We have Karen Leudel, who's a technology advisor at Fraunhofer, famous for the MP3 technology, which we all know of. Also a member of the Global 5G Advisory Board, and she's going to speak to us about how Fraunhofer is helping to build private networks for industry. Thank you, Karen.
Hi, good afternoon from Germany. I hope you see my slides.
Yes.
Perfect. So, sorry, I have to look in this direction because they are there. I could not change it to another slide, other monitor. So I will give some thoughts about 5G and industrial applications. I think you all know this magic triangle of the ITU for 5G. So this was the 3 targets to enhance mobile broadband, this massive machine type communication, and this ultra reliable low latency communication. And like it was mentioned before, with the release 15, there was only the target to have the mobile broadband. With release 16 and 17, we will have the improvements in reliable communication and low latency communication, and also additional features like positioning. And release we are just working on release 18 in the standardization. So because I'm working in SA1, so this is the group who's picking up the requirements from the market and rewording it in requirements for 5G. So and like it was mentioned, we have over the last 2 years, our main topic really was to bring in all the requirements from the manufacturers, from the automation industry. And the picture also shows that we have many branches, verticals, we name it in the 3GPP, who really have requirements. If you look on buildings or agriculture, is mainly this massive machine type communication to have many sensors integrated in the system, or with mission critical application to have this really reliable low latency communication. What is typical for the industrial customers is that they need all, so that you really need your tools tracked, your IoT devices, that you have augmented reality applications running on your premise, that you have these robots where you need low latency communication, that you have drones, that you have AGVs running. So like this picture shows, you need all aspects of 5G in an industrial application. This picture, yeah, many. The picture down to the nice colors. It's a shows a little bit the different kinds of private networks. So it can be from a standalone, isolated private network to in a public network integrated private network. And this is really a very important step for a manufacturer or for industry to really decide which kind of private network they like to install. So if they do all by themselves because they have a requirement on high security, on low latency, or if they have it operated by a public network provider. And there are many steps between, from everything done by yourself, everything done by the operator. And this has really a high influence on the latency, on investment in infrastructure, on the people and the training on the people you have in your company, how flexible you are in the changed infrastructure, quality of service, and yeah, I mentioned before security. So it's normally the first step is really to think about your use cases. And what you need, and then really to select the right kind of private network you need. This is a very simplified overview of a smart factory, but it shows a little bit that you really need a 5G. Normally the installation we prepare now with our customers is that you need every aspect of 5G, that you need the positioning for your HEVs, for your goods, for your tools, for augmented reality applications, that you need a low latency communication for robots, for process monitoring, and the mobile broadband for all this application like augmented reality. And normally it's really that we go we really in detail discuss these use cases, because you really need the exact figures, what it needs. Because normally if you say HEVs, it's a difference if you like to have heat maps, if you like to steer them with additional sensors, or if you only like to do it by one sensor. So this is very important to really understand the use case, and that's also the customers themselves understand their use cases. Sometimes not that easy. This is an example of Bob mentioned it in an introduction. There are so many use cases, and this is an example we created together with the VMA. It's the German Association of the Machine Builders. All the use cases they need in their own production, but also on their customer sites where they sell their machines. It was really that 5G, they like to use it from the flexibility of the production to the real-time applications. So the ultra latency is an aspect. So we looked, the need is that they need support in the logistics, so that they have positioning and communication, for example, for the HEVs, that they like to track and communicate with mobile control panels. I will not mention all. Behind these blue ones, there are 32 specific use cases, but it shows that with the release, we have had a look on release 16 and 17, also 15, 16, 17. With release 15, around 80% or 70% of the use cases still can be solved. And it needs data release 16, 17 to make all alive. But there were only 2 use cases who could not be solved with up to release 17, where we have perhaps to wait for release 18 or perhaps 6G. We don't know exactly. Because it's not that easy to speak every time on the customers, because they, it all their NDAs and so. So I picked up our own testbed as an example from private network. This testbed has 2 sites, 22,000 square meters. Like you see here, we have over 40 and 50 antennas in this installation. This is because if you really like to have this ultra reliable low latency, this high availability and high accurate positioning, you really need a dense deployment. So there is not the way to have one base station and everything runs. So this, everybody has to be aware of that. Private network with an industrial installation really needs a dense deployment. And also the next sentence is cables, cables, cables. Because behind the antenna, there are cables. And wireless, 5G is wireless, but you need many cables in your installation to connect all the antennas to the central unit. But the nice thing is that with 5G, you have really the indoor area, the outdoor area. You can connect the office area with all the applications. And 5G is also open to integrate Wi-Fi, ultra-wideband. So we have all the other systems running there and integrated in 5G. And also with the outdoor areas to have drones, and drones need the positioning. So we have also the connection to the GNSS system. This is one example. We mentioned before, positioning is very important. And this is the agenda within 5G and the 3GPP. So we will have the 3 meter with release 16, like mentioned before. We have 1 meter with release 17 and up to 20 centimeters for IoT use cases, so industrial use cases, indoor use cases. And the release 18, we will have device-to-device ranging, so side link, and also low power positioning. This is only one example because positioning is a little bit a favorite of me. So I like to describe with this example what a private network means. And you see this on the top, there is this remark, enhanced positioning service area. So all these high accurate positioning figures will only be reached if you have a dense deployment indoor. And now the last slide for today. This is an example of what it means to have a private network designed special for your needs, for your use cases. We used signals, release 15 signals. We have had 100 megahertz bandwidth. So this is the industrial bandwidth we have available in Germany. It's this 3.7 to 3.8 gigahertz band. And we reached with a downlink TDOA algorithm developed by ourselves, 50 centimeters without any machine learning and extra added things. So it shows that the network is designed to fulfill the purpose of your needs. And this is only possible with a private network. You can really go beyond the targets or the figures of 5G in the standardization documents. So this was the very short 10-minute speech about 5G in industrial applications. And yeah, I'm waiting for the questions and answers after the panel.
That is great. You are so on. I'm actually in Germany too, so I appreciate it very much. Okay, let's jump on to the next presenter. Erik Josefsen. Josefsen is the head of advanced industries and leads Ericsson's global industrial IoT and 5G offering. He was previously in the US in Silicon Valley doing many things, including the Connected Car initiatives and Spark Sustainable Cities Alliance. Erik, hand it over to you.
Super, thanks. Can you see my screen?
Yep, and you've got 10 minutes.
Perfect. And you see the screen, right?
I see you.
No, we don't, Erik. You just need to click share screen. Yeah.
I just need to do a click here. Come. And here I'm crashing. Do you still hear me?
We hear and see
you, but not your presentation.
Alex, I think we've lost him.
Okay. Do we want to let's sort of say we can field a few questions and jump back to Erik when he's reconnected?
I think that's a great idea, Alex.
Let's go. So I think it was let's sort of say an interesting set of presentations. One raising some questions, does 5G do enough? One sort of doing the kind of the standard rollout process. Any feedback any questions from the audience regarding that?
If anybody has a question, please, next to your name, there should be a small little raise hand function. You can just press your hand. That'll identify that you'd like to ask a question.
In the meantime, I mean, I think new technologies are always important and always relevant. The question is, what is the real what are the real problems to solve? Where do we sort of see the sort of breakthrough applications? I know Bob had talked a lot about AI, using it, sort of basically having cloud computing to the edge. So maybe to our panelists, and I think, you have different perspectives. What do you think are the sort of the big problems that will be solved from a manufacturing and industrial perspective from the 5G?
So my experience is that we have had problems in the past with all this increasing number of mobile objects, vehicles, or machinery with the increasing flexibility, so that you really change the production within weeks, months. So there's no installation running for 10 years. And as mobility is included in it's what from the beginning, the target of 5G, to have mobile objects in the network. I think this is really the big advantage, so that you can also make retrofit all these applications. This is also my experience with the feedback from the market. Also, if you sometimes not only need all this, like ultra latency, you don't need it, but you need that you can connect every device to the network and it is connected worldwide. Perfect. And it can move, no problem. So this is an advantage, I think, of 5G.
Eric, any?
So, Alex, I believe that Eric is back.
So I can answer after Eric's or at the end.
No, continue there after, and then I jump in. So
go ahead.
Sorry,
please.
my connection.
I think you're good now. Let's go.
Okay. This is what happens when you don't use 5G, but instead you use.
It's a good advertising, right? Use 5G.
Exactly. But yeah, I guess you see my screen still, or is things still moving here now?
Okay, great.
I think we have too many problems here on this. I'm gonna do like this, the following. Continue with the question. I have technology problems.
Okay.
Okay. Yeah, very quickly, if I wanted to answer that question as we discussed, one of the reasons that Wi-Fi and 4G could not do a lot and 5G now tries to do is exactly the same thing, because of the demand of the market and industry. Because now we're getting to the era that the data is everything, and making decisions real time is the most important part. And having a wireless communication that can respond fast and be reliable with low latency is the most important point. I just want to mention COVID-19 also made us to realize, even though there was a lot of discussions, that now cybersecurity is very important. So again, coming back to 5G and how the system will work compared to 4G from the spectrum perspective and characteristics of the wireless communication, these are the important parts. One of the important part is, again, when we talk about especially cloud and edge and all those kind of stuff, this timing, low latency, and specifically the bandwidth to transfer the data would be a lot important. And especially, again, I want to emphasize on that security. So different applications, of course, has different interoperability challenges that requires us to have a wireless networking like 5G, like what I said, Li-Fi in future 6G, to come together and make the future, like IIoT in general, possible. Of course, this is all demands of the market and demands of the application in a smart factory, industrial 4, and digital twins, and all those kind of things that come together and make this discussion important and defines the requirements for 5G for the industry.
Great, good. Eric, let's go take 3. So we
minutes, love it. Do you hear me now?
I do.
Thank you.
Can we see you? We see you.
And you can see me. We skipped the presentation, too much crash. Okay, we tried the 3 minutes presentation. We will see. If it is crash, then we give up. Do you see it? think you do.
Yes.
Yes, we do.
Wonderful. I think, Karen, you started with how it looks like in the factory, cable, and Ferdy, you explained that the number of connections are increasing, I think around like 150 billion. This is 100 years before I was even born in Stockholm, and this is how consumers were connected. But this is the reality still in our factories, right? We are adding cables, and of course, even with 5G, but that is the purpose that we're trying to remove, right? We skip this. If you only look into the factories alone, though, we have around 4.7 billion wireless connected devices that is predicted to 2030. Now, only in the specific factories, but that is a significant rise. Today, we have around 98% of all connections are wired. So we are on the step of the rise of wireless. When we talk to industries, we usually have to now, we go a little bit back to basic. Ferdy explained Li-Fi and all the different type of spectrum capacity. I usually have to go back to basic and say, okay, you have unlicensed, everyone can play, you have licensed, limited controlled. And that's why we can also reach some of these capacities here. Go to a little bit more to basic. You have the low bands, you have the mid bands, and the high bands. This is for the first time that we are actually introducing 5G on all these bands, which gives the optimal capacity. And when I talk to industries, I try to explain spectrum with the help of golf clubs. I think some of you guys are playing golf, and that helps. On the low bands, this is where we have around 700 megahertz that is activated here in Sweden for 5G. We get far, we get coverage, but it's not that high speed or low latency, so not as accurate when you use your driver. But then you get the iron clubs, which is on the mid band. And here we are introduced on 3.5 gigahertz, you see 3.5 gigahertz with the industrial spectrum in Germany. And soon, and especially in the US, you have high bands, which is the first time that you have the Potter, which gets extreme low latency and good capacity. But when you put all these together, you have a full suite, and that is the real great power of 5G. As we talk about industrial spectrum, that also changed the game. A lot of countries are starting to introduce it. We see that in Germany. We see also that with the CBRS spectrum. So I'm trying to address some of the concerns and the questions that we had in the overalls for this session. That changed the game. You can deploy small networks. Here I have the absolute smallest indoor antenna for a private network, which you have dedicated for yourself, gives very stable and reliable communication that can be indoor and outdoor. But where is the money? And I sometimes have cash with me. This is our own calculation. We see that it's generating $1 per square meter per day if you start to deploy a local private network. Reducing waste by connecting, I have a lot of toys, screwdrivers like these. Instead of having manual maintenance, you have just a sensor. You reduce at least some of the cabling, and you have the new digital services, which is your factory with a lot of apps. And that leads actually to around $4 million in new type of potential for your factory. So alone, you actually can justify investment on dedicated networks, because that comes as another point later on, I think, in our conversation. And across the globe, there is a lot of momentum right now. We connect Atlas Copco factories on 3.7 gigahertz just recently. And these are the screwdrivers. Atlas Copco factory in Belgium. Hitachi ABB factory, I think it was mentioned in the beginning here, Daimler, that too. A Ford factory was mentioned, it's also connected, Scania factory, and it goes on. And that was my 3 minutes. Over to you.
I think we managed to get a question. Did you get enough of your across? Are you?
Definitely. I don't deserve more when I keep on crashing. So back to the team.
I think it's your computer, not you. But let's see. Jason, do we have any questions from hand raisers?
Yes, Thomas Ost has his hand up.
Go ahead, Tom.
Thank you, Ali. I was going to ask a fairly generic question, which is it's a little difficult for a non-industry participant as an investor to understand what the timing is. So I would ask if people could be as specific about timing for these developments as possible. It's hard for me to distinguish what's already being done with what's being planned or about to be deployed. So it's really about is this a next year thing, the year after? Kind of what's the pace of visible developments? Because at this point, it's very hard for a lot of the investment community to see actually what these private networks, where they're being deployed, how they're being used. So this is a great instructional for me. But if you could try to be a little bit more revealing about timing, that would be helpful.
Eric, do you like to answer, or should I give a little bit?
I can start, and then Karin, you can help if that is okay. But overall, Ericsson is one of the main leaders in inventing 5G, you can say, together with Fraunhofer and the other team members here. Majority of the deployments is depending on the spectrum, as we talked about. When do you get the 5G spectrum allocation? In South Korea, we have had 5G up and running now nearly up to like 2 years because they were one of the first early access towards the 5G spectrum. For industries and the private networks, majority of the deployment starting with 4G and then evolves into 5G. This year, we presented our 5G standalone trial kits to be up and running, which means that you only run 5G to get better performance. Sorry. Yep. So, and there's also the type of deployment scenarios that we have today is non-standalone, just to mix 4G and 5G. So the release 16 and release 15, that is what is currently starting to be deployed. So simple answer is it depends. Majority of deployments are starting with 4G and then evolving into 5G, but the performance is increasing every time with the different releases. As 16 comes, as 17 comes, and so on. Karin, complement with more high-tech.
Not too much high-tech. It's only like you said, it was a perfect description. And if you look on your releases, we have this release 16, like you mentioned, it's now cross installations. And with release 17, which is a really industrial release, if we can say it this way, because then we have the most of the requirements implemented, is available, I think, around 23. If you say, it's my impression that we have it available in the market 23, and the release 18, which is then all the nice things around this, will be available 25. And then I think there is no open question for any industrial application. No, but you can start now. This is also, we started now with our test bed, and we have a plan to bring in each release, so upgrade it from 15 to 16 to 17. So this can all be done.
I have a follow-up question, if permitted. This is Doug Dimitrov. So did you just say that the next release, release would be 2023? Is that what you were saying? And then 18 would be release 17, then 18 would be 2025?
This depends a little bit on Corona and how we got, the speed is a little bit going down in standardization at the moment. We're behind 3 to 6 months at the moment.
Thank you.
Eric, you
I
can comment on that.
Good. Continue.
Yes, according to 3GPP, basically the plan is to release the 17 by end of 21, but they expect highly risk of delay. That's going to be somewhere around mid 2022. Now they're still 23, but as you know, the 16 release, which was focused on IoT, was supposed to release in March, April, but it released July, actually, early July. So again, as Karin said, it's going to be very, very dependent on how the Corona goes forward to finalize the 17. So 18 usually going to be another year after that, whenever it's going to be.
So the numbers I mentioned were commercial available, not when GPP is releasing it. So commercially available.
And as an investor, I think you also need to consider the number of devices also that need to adopt these releases, and hence it is always a little bit of a lag when the standardization is done and then when you start to see scale. But the answer is 5G is available. You can do it right now, but it's from the early releases.
If there is no other questions on this one, I want to give a quick thing for Thomas' questions that said from the timing perspective. Generally, if you look at Thomas, LTE has been deployed 680 as of mid-November, 680 projects. And when you come to LTE-4, 338, and right now 5G is 135 projects has been utilized globally, which Western Europe and Asia Pacific is the leading of the projects of the 5G. Just to let you.
Well, all good things must come to an end, and I think we have to move to the second session and second and last session, moderated and participated by Bob Cohen.
Hi. Let's see if my mic is on here.
But while you get organized, let's thank the panel and Alex Wolfson, who moderated it, for an extremely well-organized, well-informed set of presentations. I've learned a lot, and I'm sure you have too.
Great. Thanks very much.
Everybody. Appreciate it.
I'm sorry to interrupt. I just wanted to introduce the second panel, which focuses more specifically on case studies of how 5G is being used and how it changes the shop floor computing and communications. So this is an effort to give more specific information. But if I could just add a comment on Tom's question from before, the other people seem to try the use of 5G to the introduction of new stages in the standard. I've seen some interesting things happening, particularly in the pharmaceutical industry, where there's a great concern about disintermediation, and with some of the companies that have been able to really streamline drug development. And I know one guy who has a great deal of experience as a data scientist in the auto industry, who was just hired by one of the largest pharmaceutical companies to transform all of its manufacturing facilities over the next 5 years, regardless of what's happening with the 5G standard. They've seen this, and they've seen that if they don't move into having a much more efficient and scalable production system, that they'll not be that competitive. And I've seen that in other sectors, that the need to be competitive is driving this adoption. So we have 3 speakers here. The first one is going to be Eric Simonson he's head of Ericsson's Smart 5G factory in the US in Plano, Texas. The other speakers will be Niels Koenig who heads the Department of Production Metrology at the Fraunhofer Institute for Production Technology, and he'll give use cases related to the 5G Industry Campus Europe that is in Aachen, Germany. And the last speaker will be Chuck Byers, who's the Associate Chief Technology Officer of the Industrial Internet Consortium and an independent consultant who works on the architecture and implementation of large computing platforms. And he's going to talk about how AI operates in support of 5G networks to optimize RAN and security, and how 5G networks are enabling technology for AI. So if Eric could start first, that would be great.
All right. So hope you can hear me okay. And thank you for the introduction, Bob. I will go without slides, actually, and I will tell you a bit more of a story of what we've done and a couple of and then also a bit of implication to the workforce we see in the environment that puts on us. So as Eric introduced earlier also, when it comes to spectrum, the high band spectrum gives low latency and throughput. So what we've done here is that we've introduced a private 28 gigahertz network. So we have 13 radios and a radio core installed in the factory. And why we installed 5G is really tying back to what a lot of people said here before in the panels. So one is, of course, increasing competitiveness and looking for productivity increases in the factory. Number two is really to make sure operating factory. It's not a proof of concept setup. So that we can see effects of this as well. Yeah, and as mentioned before, when it comes to 5G networks, 5G private networks, it's a security aspect in this as well. So we can control access of different devices also on how the traffic goes through the network core. So with that, since we have a fair amount of security or sensitive information in the operations as well, then we can control that also with 5G. So if we look at a couple of the practical use cases that we are working with here, and that is coming to life already now. So if we talk about timing, it is available and we're doing it now. And then, of course, with 17 and 18, it will be improving. But augmented reality and autonomous mobile robots, or AMRs, it's also referenced as AGVs, but the mobile robots. So starting with the augmented reality, I mean, in itself, it's not a new technology, but what we do see with the high rate of data throughput and the requirements of speed and latency that we see that this brings with it, also how the engineers are starting to use the technology. We referenced COVID, for example. Now there has been a very strong driver in the digitalization when we cannot have people on site. So with 5G, the throughput and better jitter consistency, it helps to maintain a smoother video with many of these AR use cases. And what we see is going for more simple image or static signage, and we can take advantage of the throughput and higher frame rate also, and the lower latency. So for example, we have use cases where we do remote for service or fault finding troubleshooting in our environment. And then you don't just work with static images, you start to also increase the 3D images combined with the video rate. So once again, back to the latency and the much better experience for the end user when it comes to frame stabilization and how we use it. And the efficiency gain is quite clear here as well. We can a lot quicker go to help resolve problems out in production. And this is also where we see a bit that it's getting closer also to what we see in the gaming industry. Latency becomes a factor. So this becomes a real life experience also when it comes to the operators and the technicians, the ones that are really using the use cases, if you wish. The other piece of things that we do here is around autonomous mobile robots, AGVs. So traditionally in the past few years, it's been connected over connected over 4G and Wi-Fi. Karin mentioned the positioning, but we also see that in Wi-Fi we've had problems with handover points or blind spots, which actually decreases the productivity and limits the speed on how we can run the AGVs, or it also limits a bit on how flexible are in running the AMRs. So instead of running them on fixed routes and messaging, we can with 5G we see that we both can increase the flexibility in terms of the mapping. We can also with more and more video coming into the sensor technology on the AMRs, we can also introduce sensors, and with a higher throughput and lower latency, we can detect obstacles in production that traditionally is not fixed. So pylons, different pallets, and so on. So over time, I will be able to see around corners with the AMRs, and it is very much dependent on the 5G technology. And the last piece of things is also when we talk about the real-time analytics, the changes in requirements of the workforce. So we see differences in many areas of the operations. So first of all, the skills of the operators and the technician that differs in the way that you need to have an ability to adopt this technology that the use cases create. It's also different on how we interact both with the equipment and the technologies in production. So when we have an environment where machine uptime flexibility, as we mentioned, is becoming increasingly important, also requires more agile and upskilled workforce. So one example also now that we see when we do these practical use cases is that the operators and the technician, they also interact to a greater extent with the data scientists and the people that are developing the use cases. So it also requires that you need to start to understand and adopt to the technologies. And as we've seen here in examples previous on the panel, going from 5G to 6G or Li-Fi, as was mentioned, this requires also that the workforce on the production, on the shop floor, needs to also be upskilled. So we move away from that. You're set at a position, and then you're trained for that specific operation, and then you do that a bit of rotation in production. You also need to start understanding the technologies around us. And then with the low latency, also we talk a lot about mobile edge compute. So allowing offloading of the increased compute needs that we have on the devices. So this ties back to the flexibility as well. So an example could be a decanting robot unpacking material that has some limitation in the onboard sensors. And with the mobile edge compute, we can implement more of the camera-based sensors to be faster and safer. And also, if we move this around, we're also less dependent on the stationary position of this device. So you can easier also send new recipes or, let's say, instructions for this robot to update itself towards the different operations. So this all that. The private networks and 5G gives us. So that's my few minutes story about what we do here and what we see. So with that, I will hand over to the next speaker.
Okay, so Niels Koenig is the next speaker. If he could go ahead.
Yes, sure. Okay, so I'd like to explain you about the 5G Industry Campus Europe and the use cases that we are implementing there. So first of all, some words about the 5G Industry Campus Europe. What is it? And some preliminary, information about how we see 5G contributing to data-driven production. So maybe you have seen similar figures like shown here. So that's how we understand data-driven production. So on the bottom layer, we have the physical layer, which is actually the shop floor, where you have all the real machines and the real parts and the real work pieces that you are producing. And then on the second layer, we have the data layer, where you aggregate all the data coming from production, may it be machine data, may it be sensor data, may it be inspection data, and so on, or simulation data, etc. And so on the physical layer, you have the physical parts. So that's actually your product. And on the digital layer, you have the digital twin, which is actually the sum of all the data that you are aggregating and transmitting. So 5G here is actually one of the possible and very attractive links in order to connect the two layers. So it's not the only one, of course. You still have wired connections as well, but 5G can replace a lot of other communication technologies directly. So that's actually the background why we created 5G Industry Campus Europe. So the 5G Industry Campus Europe is an industrial 5G testbed. It's a private network. That means that we operate the network on our own. There's no mobile network operator involved. And we can run this at the so-called industry spectrum. In Germany, companies and entities have possibility to actually apply for a license in the range of 3.7 to 3.8 gigahertz. That's what we did. And we connected 5 different shop floors with indoor networks, 5G indoor networks. And all of the shop floors are connected with multiple machines and robots and a lot of production equipment. And then furthermore, we are close to put online a 5G outdoor network of 1 square kilometer on the campus of the university. So it's a campus network in a double sense. And we are operating the complete setup at the 5G non-standalone architecture. That means that we still have a 4G core, but we will switch that to 5G in the next year. So our network supplier is Ericsson. So all the equipment and the network setup is coming from Ericsson, and we jointly integrate this 5G network also into our shop floor LAN or shop floor network as well. And then we have 2 other research institutes, not only from Hannover IPT, but also 2 institutes from the university. So what is actually the vision of the 5G Industry Campus Europe? It will be the entity in Europe for holistically explore 5G in manufacturing and logistics. And by our knowledge, this will be actually the largest testbed, private testbed in Europe for production. And as you know, there's quite some heavy investment for companies starting with 5G. So just a few companies were able to actually invest and start with 5G networks. But the majority of companies is not able to start with own networks. So this is actually a platform for those companies to jointly explore 5G in a very early stage. So we look on real world use cases, looking at the real manufacturing challenges, because that's actually where we are coming from. And we are doing this as a single site perspective, as also cross site, because as you can imagine, having multiple shop floors with indoor networks deployed here, as well as an outdoor network, actually gives you the opportunity to explore, let's say, enterprise-wide connectivity cases as well. So as an overview, the use cases that we are looking at right now and we are developing right now, so there are different use cases. I'm not going so much into detail due to the time restriction. So there's activities in sensors like acoustic emission sensor. I'm going to explain in more detail later. 5G robotics is looking at mobile robotics for basically assembly. It's not to mix up with logistics, which is the next one, where we look at the classical, let's say classical AGV use case, which you have seen all around already. And in our case, we are also testing from the transition from indoor to outdoor and from outdoor to indoor as well. 5G cockpit is a cross-site connectivity solution, so an end-to-end connectivity solution to remotely connect to machines and wireless devices on any shop floor within your enterprise. Very important today, as we know. So a multi-sensor platform, that's what I'm going to explain later. Then we are exploring in 3D, an optical 3D scanner. Then furthermore, what is also maybe interesting for you to see is we have integrated an edge cloud platform. So it's this kind of OpenStack Kubernetes Docker system that you see all around. It's integrated with our 5G network and integrated with our production IT as well. And of course, this serves as a low latency computation hub for all the use cases. So let's have a closer look at one of the use cases. It's coming from milling. So this is jet engine from Pratt & Whitney. And in the middle, you see an integral part. So it's a blade integrated disc. So this is being milled from one piece of metal, a disc of titanium alloy. Very difficult to manufacture, very difficult geometry. And you have these blades. And the blades is actually a tuning fork, meaning that the blade can resonate because of the milling process. That's something that you cannot actually avoid. And what you actually then do is you connect the complete machine. That so we have a complete monitoring solution. On the one hand, extracting all the data, the real position data from the machine. So you have a coordinate system, and then you integrate different kinds of data sources. You can integrate data sources coming from simulation, like model-based approaches, for toolware, for cutting edge offset, for part deflection, part bending, part vibration. Then also the tool can have some deflections. So putting all of these sources in one digital twin gives you a lot of opportunities to learn from the process and learn from the real data in order to be able to actually manufacture this very delicate and safety critical part. So you have to imagine like this part is being in the machine for more than 40 hours. So, and the budget for a standard component, state of the art, is like 40K euro. And the new geometries resulting in less fuel consumption, they are much more expensive and much more delicate to manufacture. What can happen actually when manufacturing this kind of component? You have vibration of these blades, very thin walled. Very high twist. And you can see in the top left photograph what happens with the surface. We have a waviness on the surface, which is actually quality flaw. And this is something that you want to totally avoid. So you have to know what is happening actually with the blade. You could simulate it, but actually at the same time, it's impossible because this component loses volume, loses mass, and so the vibration behavior changes over time. So you want to have the result as a smooth surface, as you can see on the right. So you have to control what you are doing with your machine. And this is actually what we do with the help of 5G. So you see this kind of data flow diagram. You have this milling machine on the left bottom side. Then we developed a wireless vibration sensor, an accelerometer, with a small PCB doing signal processing, pre-processing, calculating the FFT. So the result is then the frequency spectrum that we generate as UDP packages and transmit via 5G wirelessly, of course, and then feed back into the shop floor IT. Then we go back via Ethernet. Why Ethernet? Because the machine doesn't move around, so it stays there all the time. So there's no need to have a wireless link to the machine. So we have, as you could say, it's a hybrid closed loop if you want. So we go back with the signal back through different kind of electronics, which are then linked to the PLC, to the control of the machine, and then we can, in case we have a strong vibration, we can control this the velocity of the spindle in order to get out of the resonance frequency window. So next approach is then as well, in case you operate multiple of these sensors at the same time, you have a more scalable approach, doing all the signal processing in an edge cloud. That's what we also have in place. In our case, we have a platform from German Edge Cloud, which is, as mentioned, an OpenStack-based Kubernetes system, very flexible. You can pop up multiple virtual machines. For example, one virtual machine per sensor would be possible, and of course, you can enable easily remote access to any site in the world. So here's the result, how it can look like. In our case here, we have the vibration amplitude mapped over the geometry. So we've used the signal coming from the sensor on the 3G geometry, the 3G coordinates that we extracted at the same time from the machine. And you can see how it nicely correlates with the photograph on the left side. You see the waviness on the surface again. And at the same time, at the same place, you see this red area where you see that there is a high vibration amplitude. So you could say you have a process diagnostics which comes more or less for free if we have 5G on your shop floor and you have this kind of sensors. So the sensor is of course not off the shelf. That's something that we have to develop because it's not available on the market. Next example, it's on looking on the tool, because a lot of bad things can happen with the tool. So the milling tool, for example, you have tool breakage due to tool wear. That's where 5G also comes into play. I've prepared a video. I'm not sure if you are able to hear the sound of the video and hear me explaining it. Hopefully it works. Otherwise, if you don't hear any sound, then please tell me. Oh, sorry.
Hello, my name is Nils König. I'd like to tell you something about toolware monitoring.
I don't hear the sound myself. Can you hear the sound of me explaining?
These kind of tools are used for manufacturing. Okay. So in conventional machining, like milling and turning and so on. So as you can see, the cutting edges, these are in the interaction with the material of the workpiece. And they are typically naturally affected by tool wear. So that means that part of the cutting edge can break out. What companies typically do is they either estimate what is the tool lifetime, so the cutting volume they can spend with the tool until it's worn out, or they can monitor it. So monitoring today can happen with acoustic emission. So acoustic emission is actually a high frequency sampling rate monitoring of the acoustical wave inside the material. So that means as soon as the cutting edge interacts with the material and carves out metal,
you dropped out.
Then you will have an acoustic
wave,
and this is being recorded with 1 megahertz.
I hear it fine on my end.
You hear it fine on your end. So in case you cannot hear the sound, then I of course can explain it maybe after the video. I continue.
Sampling
we can hear it, but we must move this towards the end now.
Conventional drilling tool,
okay.
Which
so
we
then, so maybe what you could see here is actually the sensor. It's actually the sensing probe, and then we have some electronics as well, some PCB that we developed, some FPGA-based board, and then we go via an Ethernet connection via 5G gateway, which is not yet a product; it's a prototype. From some company, and then we feed back the signal via the Ethernet on our shop floor, and then this results in this waterfall plot, as you could see here. I think you could see it here. So this actually gives you a fingerprint of the cutting edge, right? Okay, so then let's go quickly. So this again a data flow diagram. So we have the sensor inside the machine. Why inside the machine? Why 5G? Just to explain that, it has to be inside the machine because, as you could see in one of the videos, we have a 5-axis milling process. So there's a lot of movement inside the machine. So cable is a very bad option. And it has to be 5G because we want to be able to react immediately as soon as we have a critical incident like this vibration or a tool breakage, right? Or a collision, even worse. So you can damage the complete spindle of the machine, then it's like 30, 40K damage. So you have to avoid it using this kind of sensors. A wireless system, of course, it's much easier to retrofit. So these acoustic emission sensors are state of the art today already. For example, in the automotive industry, in the aviation industry. But you can imagine integrating this kind of sensor means completely dismantling the machine in order to feed the cable from within the machine room and to the cabinet. So, and of course, a wireless system is much easier, and yeah, it's a great relief for all the machine operators. Okay, these are just 2 examples of what we are doing at the Fraunhofer IPT and the 5G Industry Campus Europe. So we are going into the machine. We're going to literally to the cutting edge, and yeah, that's receiving great attention from the producing companies. So as you could maybe see that there is a lot of potential for production coming from 5G, and I think it was clear also from the presentation of Eric that 5G campus networks can be realized already. So the solutions are there, but there's no ecosystem yet in terms of the production equipment enabled with 5G. That's still a way to go. Of course, standardization is a must here, and yeah, it takes a joint effort from the IT and the OT industry, and the organizations like 5G ACIA are actually the key organizations in order to drive, or let's say to put the base ground for this ecosystem.
Thank you.
So thank you very much.
Thank you very much. Bob, we have one more speaker left, is that correct?
Yes, that's right. Chuck Byers is the next speaker.
Okay, we are kind of at the end of our time, so we would have to squeeze everybody's comments forthcoming now. Please, thank you.
Okay, hopefully you're starting to see my screen now.
Yes, go ahead.
Wonderful. Okay, I'm Chuck, and I'm going to talk a little bit about how 5G networks enable AI, and also how AI supports 5G networks. Here's an example of what you might be looking at in a typical industrial private network using 5G to, for example, control forklifts and cameras and mobile devices in a factory setting. It consists of a number of layers of computation and potentially layers of AI capabilities. We start in the cloud. We go to the multi-access edge computing nodes, which are often located at the base of 5G cell towers. The 5G cellular radio access network infrastructure is itself intelligent and has capabilities to do quite a bit of stuff. There are multiple distributed edge nodes around the factory floor. Some of them might be acting as 5G to wired gateways, for example, to plug in an Ethernet or PoE security camera. We may also use these to directly connect to various machines and other devices running around. The forklift itself is probably a 5G client. It has its own potentially autonomous control infrastructure on it. It has various safety systems that we need to interrogate. So let's talk a little bit about a forklift safety application that uses this 5G private network infrastructure. It's designed to avoid collisions between the forklift and objects on the factory floor, pedestrians, and so on. It does this by using, for example, some sensors on the forklift. Perhaps there's a LiDAR scanning in front of it. And it fuses those sensor readings with other sensors, for example, the security camera, in order to make decisions about there's a danger imminent. Some various layers of AI systems are required up and down this infrastructure, and I'll add them as I go. So there's some AI that might be available in the cloud. Certainly the training phase of AI that's adapting those models would run in the cloud. Then there might be some AI a little bit deeper in the ETSI MEC nodes where we really want to understand what's going on down deep in the network. Then there might be some AI in the radio access network helping us to monitor and adapt the functions of the 5G private network and the functions of the 5G air interfaces. There's certainly AI in the forklift, especially if it's autonomous, that's controlling its operation, and that's a mobile AI platform that rides along with the forklift. We may have AI in the edge node that's responsible for various functions associated with keeping the edge node running as expected, and also associated with supporting the peripherals and IoT devices below it. Finally, some sensors themselves are smart and have AI capabilities. So that camera might have a processor in it that has programmable AI or machine learning functionality. Now let's take a look at what parts of this forklift safety function we may end up with in each of these layers. So here we might be adapting contrast, a fairly simple problem, but something that AI can help us with directly on the camera. We may be taking those video images and extracting features from them, discovering that there's a human walking, for example, and the features that make up that human. We might be doing autonomous navigation on those forklift processors. We might be doing precision location as part of the radio access network, timing flight times and arrival angles and so forth to determine very precisely where the forklift is operating. We may be recognizing objects from the cameras or from the forklift LiDAR in the MEC node. The latency there to do those object recognitions is much smaller than shoving it all the way to the cloud. And then finally, once objects are recognized, we can go up to the cloud and detect hazards and use those hazards to, through the very low latency 5G detections, determine that it's time, for example, to apply the brakes to the forklift in order to avoid a collision. So this is an example of all the different layers of AI that might appear in a 5G private network and how they support an industrial application. For example, pedestrian safety in areas where autonomous forklifts are running. We can turn this entire picture upside down. And this one just demonstrates how 5G supports AI, but let's use the same models and talk about how AI supports 5G. So we have the AI functions in exactly the same places, but now what we're doing is using, perhaps on a time-sharing basis or different cores in the same AI processor infrastructures, we're using this infrastructure to help us control and optimize the 5G network. And let's give an example of some things that those AIs might do. The edge nodes might be doing interference detection. So maybe every morning at 7 a.m., the electric arc furnace starts up to melt the metal for the day. And that's the thing that AI can detect. That interference might be able to discover where that's coming from. The forklift, as it's running around the factory, might be able to detect dropouts, places where there's signal deficits. And it can actually make maps of the signal quality and make those signal quality maps available to help optimize the 5G network. That's an AI function because there's quite a lot of adaptivity and machine learning involved in discovering what the radio propagation performance of the network is. The MEC nodes, the edge nodes at the base of the cell towers, might perform network load balancing. So they may decide, for example, which portions of the traffic should go through the public portion of the radio access network and which other portions should go through the private network. And if the private network is unbalanced, we have the option, for example, in case of an overload, to push a portion of that traffic onto the public network. The cloud is responsible for the whole optimization of 5G, not just this individual cell, but a whole suite of cells. It can also potentially use different access modes like Li-Fi or Wi-Fi or fiber optic connectivity as necessary. And AI is helpful to optimize the performance, reliability, and cost profile of those networks. The other thing that 5G optimization in the cloud can do is command changes deeper in the network. So, for example, I can change the multiple input, multiple output antenna configuration associated with that cell phone, that cell tower in the RAN, to maybe help redirect the traffic and redirect the radio waves in more optimal ways to avoid some of the dropouts to that forklift, and that would preserve that safety application. Finally, all of this layers could say, whoop, I might be a little overloaded. Let's scale the bandwidth that sensor is producing. So instead of producing 8K video at 100 frames per second, maybe I'll produce 1K video at 5 frames per second until the local overload condition is passed. So in conclusion, what we're really seeing here is that we have a hierarchical collaboration between AI and 5G networks. The private networks are helpful because of their capabilities for predictability and security. And of course, the functions that we were talking about being supported by these AIs are mission critical and perhaps life critical. So a private network makes sense. A lot more work on these topics being done in the Industrial Internet Consortium. And if anybody would like to talk to me about getting involved in inventing the future in these spaces, feel free to get in touch. Thanks.
Thanks very much, Chuck. That was great. Ellie, do we have time for maybe one question? We sort of started late.
Yeah, well, let's take one question, 5 minutes, and then break up. I know people have other things on their calendar, so 5 minutes, all right?
That's fine. Does anybody have a question?
I see Thomas Alst has his hand up.
I'm afraid I didn't take my hand down. So.
Oh, okay.
Let me let somebody else go.
Jason?
Yes, Ellie.
Anybody else?
Yeah, one dimension that we haven't really looked at is what kind of throttle points there might be, or what kind of problems might arise. I thought the last talk raised the issue of latency and some of the efforts to bring data back to the central cloud. Is that going to be a real kind of break on the rollout of 5G private networks, or are there other breaks you think are more important?
Certainly, latency is one of the big reasons to go to edge computing or multi-access edge computing capabilities. And by shoving the computation, especially the AI functions, deeper into the network, instead of the 80 to 200 millisecond latency that you might see for a round trip from a sensor to the cloud and back to an actuator, you might be in the 1 or 2 millisecond range. Many industrial processes will be unstable at 80 milliseconds, but can stabilize at 2 milliseconds. Lots of other reasons to go to edge, but that's one of the critical reasons why we think around 40% of the internet traffic will be processed by edge nodes in the coming years.
Great. Thanks very much. That's very interesting. Okay, I think that wraps up the second panel. Sorry we didn't have more time for questions. Do you want to just sign off, Ellie?
Yes, let me just, before thanking everybody, announce our next event, which is in about 10 days or so, on Tuesday, December the 1st at 10:30 again for an hour and a half. It's about a related topic, also on 5G, not just 5G, and it's about empirical research on the impact of recent spectrum auctions on the market structure. In other words, what have the recent auctions done to competitiveness, non-competitive stratifications, etc., of various segments of wireless markets? It's going to be led by David Salant. So 10:30, Tuesday, December the 1st. And now I'd like to thank very much to the people who made this possible today. First of all and foremost, of course, the speakers who gave the time and their knowledge and came from far off places in Europe mostly. And so for them, this is already evening hours when we are still at lunchtime here in the United States. So thank you very much for enlightening us. This was really, really interesting, particularly since usually these discussions end up talking mostly about social networks and entertainment and so on. So now we dealt with industrial processes, which was really, really great. And in particular, I'd like to thank Jason Buckwitz for running administratively this event and in many other ways too. And to Bob Cohen, who made it all possible by organizing it and making it happen. So thank you very much. And thank you, the audience. And maybe we'll see you in 10 days. See you. Goodbye.
Bye.
Thank you.
Bye.
Thanks very much.